on the surface. There's two types of BJT, which is NPN BJT and also PNP BJT. So first of all, we're going to look at NPN BJT. NPN BJT have two N-type regions are separated by a thin P-type region. As you can see from the name of itself, it's very explainable. The N-type emitter and an N-type collector from PN junction with the P-type base. When a small current applied to the base terminal controls a much larger current flowing from the collector to emitter, causing it to amplify, making it able to amplification and also switching. Right? For the PNP BJT and also PNP BJT. From what we see here, it is an operation of NPN BJT. So first of all, NPN BJT have a base emitter junction that is a forward bias and a base collector junction that is a reverse bias. We can see here the emitter is heavily doped with electrons, N-type, providing the high density of charge carriers. Therefore, the electrons can diffuse easily from the emitter into a thin, lightly doped base P-type. Because of this, the base is thin and has few holes, and only a small number of electrons can recombine into that holes and creating a small base current, which is called IB. Most electrons continue to the base collector junction, where electrons are attached to the positive voltage at the collector, forming a collector current. When the electrons flow through the external circuit, it will return to the emitter, completing the circuit. Therefore, we can see that a small base current controls a much larger collector current, allowing the transistor to act as an amplifier or a switch.
Okay. Thank you, Muhammad Arif, for your explanation just now. Okay, now my name is Muhammad Hakim, as Arif introduced me from the start, and I will explain to you guys about the characteristic of BJT. Okay, so basically characteristic of BJT consists of two that take a crucial part to know whether it is BJT. Firstly, it is physical and operational characteristic, and second one we can look at the connection characteristic curve. At the final part for our discussion, which is the limitation, future development, and sustainability. Okay, so there are three things that I will discuss, which is the brief amplifier or switch relevance. Number two is phototransistor, and last but not least is power and the thermal issues. Next. Okay, so number one, the brief amplifier or switch relevance. Okay, so while BJT are excellent for certain tasks, they have specific trade-off. So BJT could have some trade-off. So the current control, unlike MOSFET, which is voltage, BJT requires a constant base current to stay on, which consumes more power in standby. Okay, so linearity, they are preferred as amplifier because they provide a very linear output, but as switches, they are slightly slower than model field effect transistor. So that is the limitation for the BJT. It is excellent, but it is much lower compared to other model field effect transistors. Okay, so number two, it is phototransistor. Key development in BJT technology is the phototransistor for our future development. So we can see that the key development in BJT is phototransistor. So for the mechanism, it is used like instead of electrical current to trigger the base. So for our future development, this is very good. So we just use light instead of electric current. For the application, it is used in opto-isolators to protect sensitive current from high voltage spike by transferring signals via light rather than physical wire. So